Hello, everybody. Thank you again for joining in. Thank you again for tuning in to our two-part series. So, uh, just a little bit of a disclaimer. This is our opinion, our version of how we have implemented ML projects in the past. A few projects together. That is, we're collaborating and combining some of the ideas together to form a cohesive way of saying, hey, this is something that has worked for us, right? But obviously, the ML space is something relatively new, and 6 months down the lane, we might see a lot of changes to the documentation. So again, let's keep it in an opinionated way, saying, oh, this is what we have learned. Discussions are welcome. And more importantly, one of the purpose of me presenting this today is to say, this is where we have combined some of the ideas together. Let's collaborate now, right? So after this, let's take it as an opportunity to start collaborating and building together a version of ML that is sort of adaptable in multiple ways across projects. And trust me when I say this, right? So last 3 to 4 weeks, I've personally seen like 8 or 9 proposals of ML projects, being requested by the client. So the demand is high. I think we need something which, combines them together into a simple process-oriented view. So what we're going to talk about today. So this is a 2-part process. So there are 6 steps according to us. So the client comes to us and says, I need your help setting up a brand new analytics hub for me. I have some amount of maturity in my data. I want to set up ML, a structured way of doing ML projects. So we come in, and what do we do? Ideally, we should go through these 6 steps. We should talk about, level setting a technical cadence, assessing their maturity. We have tools and capabilities. We'll talk a little bit about that. Then we'll say, okay, what you need to enable your data scientist and others, right? So setting up the environment, the implementation process. We'll talk about the process, and then we'll talk about parts of it, which is like for enabling a data science or a machine learning project, you need to enable the data, the building of the model itself, and the industrialization of the model itself. And then we'll talk about the component view, saying if somebody has to build these solution through technology, what are the building blocks we need? And then once we have established how to build and operationalize a model, the question is, who are the right users? Who are the personas, right? So that's point number 5. And then the final part is, what is the life after the model deployment? So what is the ops part? What is the deployment and retraining part? What are the important things that we need to focus on after the model is deployed, right? So 6-step agenda into what should be an end-to-end process. Let's talk about the first step, right? The point number 1, what is the technical cadence? How do we level set and say this is the process? So we think any project should go through an initialization phase to an industrialization phase, right? So there are 5 major phases for implementing a project. So let's talk about the key processes and the key outcomes in each of these 5 phases. Again, this is a representation. So the key outcomes that you see, I'm trying to put the key outcomes into a monetary way, because money, according to me, is the most important motivational factor to decide whether you're going to pursue that project or stop the project, right? So again, it might not be money for certain clients. Certain clients, it can be an email confirmation or an approval through a particular process or step, right? But anyways, this is a representation of how we think it is. So step 1, you start with the project idea. Typically, the project that you want to build out should be associated with a business use case. So which means the ownership of the project has to come from business. You cannot just come ahead, you can do your POC, but it is not for a business outcome. So importantly, when we talk about an actual client, when we talk about an actual project, an ML project, it has to come from top down. It has to come from business, saying this is the business problem that we're trying to solve. And the key outcome is the business is going to come down and say, this is my seed funding. This is my initial funding. I want to set up a team, onboard the team, and solve this problem. So next step is onboarding. So this is where we onboard people, give them the technology resources, and get them access to production data. We'll talk about the access and the need for production data later, but this is the second step where we have ensured that with the right funding, with the right motivation in terms of business alignment, we have onboarded the right team, giving them the right access through tools and technology, and provided them access to the data. And the key outcome is now the team, the project team, is actually physically onboarded into the data lake, into the experimentation area, and they can start playing around with the tools and the data. Then we talk about the POC phase. Again, it's very important that we divide the outcomes into POC, MVP, and industrialization, because in actual world, what happens is if you do not demarcate these phases, we have seen in the past where your POC phase will run for 6 months. Now you have to time box things. You have to have a business outcome. And hence, again, for every project you might not need one, but it is important to see and demarcate between POC and MVP, because you cannot burn through the cash just to prove out a better technology solution. The outcome is to be business driven, right? So technology is just an enabler for this. So what entices the entire POC phase is the ability to do quick prototyping, quick business validation, quick feasibility study, whatever out-of-the-box capabilities are available for self-service, EDAs, data quality, profile evaluation. Again, the idea is low-code, no-code. Ability to perform auto-ML, because we are not talking about the accuracy yet. We are talking about the feasibility. So through a POC, can we provide enough confidence back to the business and say, with your seed funding, we have not done a lot of coding, we have been able to get the data, do a lot of quick and dirty ways, and give you the outcome. And then the key outcome of that POC phase is the business says, yes, whatever you have delivered makes sense to me, I'll give you the OPEX funding. That's where you start industrializing the code, right? You talk about actual segment separation between data prep, model training, data pre-processing, whatnot. And then when you have built the model, you plug in your fairness, your statistical fairness, your ethical, bias and fairness evaluation, your model interpretation, all of that together. And then finally, once you have a pretty good model, available, you integrate the model with model registry, feature store, model serving, all the good things, and then you package the solution. That's the point where the business says, yes, this is what I want. You have done it in an experimentation phase. It has everything, all the bells and whistles. Now I'm going to give an CapEx funding, and let's now deliver this solution that you have built into an operationalization stage. That's where you get the business approval, you get ARB approval, you onboard the right hypercare team and run and support team, you do the PI planning, you fix a release date, and then you deploy the model as a product, right? So at this point of time, as a data science project, you hand over your project to a run and support team, and the run and support team now goes ahead, starts maintaining that model, and you go back and you solve another problem. So this is a technical cadence and a process I think works. It really simplifies and creates a lot of structure to how we should go about implementing an ML project. All right, so second step we talked about, right? So now step one, we talked to our clients and said, guys, 5-step process. If you go sequentially through these 5 steps, you will see value. You will see a lot of cost saving. To Jim Lee's point, we might not have an ideal state every time, but again, that's a different story. For today, let's say that step one is we educating the clients, we ensuring that through process, operationalization process, guardrails, we ensure these 5 steps. Second question now becomes, what do we want our clients to attain? How can we ensure value? And how do we ensure that the clients are actually moving or trending towards the right directions? Right? So a lot of time, unlike data in an ML world, every single client will have some kind of a footprint, right? And like some clients would have a very small team who does some work, on a sideline. Some projects will have very dedicated data science team. Others are very mature. So second step is we as Accenture, we come in and we start evaluating what is the maturity index. So again, we did the study, we worked on it through some of the project implementations, and we have a 5-phase or 5-tier maturity evaluation for our clients. So phase 0 or tier 0 is the manual experimentations, right? So again, you might not see all of that, but again, there are certain capabilities that we evaluate, and within the capability we understand whether, let's say, data enablement, and it says batch data sourcing. Do we have at least the minimum requirement that we can bring in onboard batch data? And generally, this is again back to your point, right? So we start assessing the client, saying, you know what, let's assess your maturity. And if you're clicking some of the boxes, then you are now in a manual experimentation phase. You are in tier 0. And we want to take you to a tier 4. So tier 0 to tier 4 will be the 5-step process. So from manual, we want to take you to a fully hands-off process, but it goes through multiple hoops. So tier 1 is a process foundation, or it's a repeatable phase where we start enabling certain other capabilities. We say, okay, we can enable batch data, we can enable streaming data. So all the data initialization, all the data pre-processing capabilities, all the exploratory analysis capability. From model development, we have certain capabilities that we can evaluate and enable, right? So just by enabling or bringing certain capability modules to our client, we can move them from a manual experimentation phase to a tier 1 process foundation phase to a commercialization phase where a lot of these boxes are lightened up for them. It's a reliable phase to a scale out phase. So scale out phase is, if you see, a lot of this is done. Probably there's little less automation. We didn't talk about explainability and reliability and biasness and fairness of the models, but on and all, the model works. So all of that becomes a scaled out phase. And then finally, it's a no-touch ML phase, right? So this is where, one, we evaluate the client. Two, we try to understand which of the boxes they are enabled with, and then give them a roadmap and say, you know what, to do that step 1 to step 5 in the process flow, you need to have a lot of maturity. And let's evaluate your maturity, and we can show you which boxes you are missing, which boxes you are already sort of ticking, and let us take you through a process journey. It can be a 1-year journey, it can be a 2-year journey, but you'll see a lot of value. You can see these capabilities now enabled for you, right? So this is our second step, where first one, we talked about the process. Second one, we talked about their maturity. We assess their maturity, and we build them a roadmap saying, how can we take them from sort of a very manual driven way to a no touch way. Now, third one, so we talk to our clients about what is the process, what is the maturity. Now the question is, they have a project, where can they do the project? Typically the question again becomes, can we start doing an ML project in a dev environment, where I've never seen any large data lake house projects where they have the right data in the dev environment, right? So dev environments will never have the data. Question is, where do you do your ML experiments? If you start doing your ML experiments in your dev environment with cooked up, all synthetic data, you run the risk that the model building, experimentation, promotion, and everything else is going to take forever. So most of our clients, and that's where we have gone into our clients and suggested them, saying, you need something called as a production sandbox. This box here. The production sandbox is a logical construct within your data lake in production, which means we are talking about setting up an independent location within your data lake in your production, where the production sandbox will now have access to your silver or curated data, gold data, and if you have any kind of data mesh, data products that you have registered, those data. And these are only read-only access, which means a person can read data from silver, from gold, from data marts as a read-only copy of the data, and that too through access control possibilities. So this sandbox is a purpose-driven area where we onboard projects, and on those projects we onboard resources. They are in that resource on that project for a duration of time. During the duration of the time, they would have access to production data with access control, of course. And then within the sandbox, what we do is we start providing project level access. So we have multiple tenants in that sandbox. We have a project tenant, 1 project tenant 2. If there are 5 projects running in parallel, there will be 5 projects. Each project is again a separate section within the playground area, which means all the data that I have onboarded or I have created by connecting the data from curated gold and redshift into that project 1, that data is not accessible by anybody from project 2, and vice versa, right? So the sandbox here ensures that 1, we have secure access to the data. 2, we can build and store our intermediate data. 3, we have access to all the right tools and capabilities. And 4, when we use our tools, get our data, build our models, we can actually publish the model locally and get it verified by business, right? So it becomes a fully functional independent location, obviously with a time constraint, saying I can now onboard a project team here. They would get automatic access to certain tools and capabilities. They would have predefined rules to go and collect data from their required data set. They can start building their models. They can start evaluating the model with the business. And all the POCs and all the MVPs should be done here. Production sandbox is also an account, right? So again, depends on how do you set up this environment. So let's say this is a production setup, right? This is a production data lake. A production data lake is a logical unit. Physically, it can be created by multiple AWS accounts if it is an AWS. So your bronze zone can be a dedicated AWS account on its own. Your silver zone will be a dedicated AWS account on its own, where you have cross-account access between silver and bronze. So processes running on the bronze zone can push the data into the silver zone, although they are 2 independent AWS accounts, which means there are 2 different access controls, security points, CMK keys and whatnot. Similarly, your gold and your redshift might be installed in respective physical separate accounts, AWS accounts. And similarly, your production sandbox can be a fully dedicated AWS account. All these 5 AWS accounts, in reality, when we did a project like eTrade, we had 9 AWS accounts. All these accounts can be logically combined to create one single production data lake. So this is a data lake where your production sandbox is one of the physical accounts that corresponds to the entire logical construct of a production setup. Now, this being an AWS account, you can connect to that AWS account in any ways the client wants you to. So it can be through a jump box, it can be through an AWS console, it can be through an AWS Accenture laptop, depending on what the client wants, or however else other ways you guys have worked on an AWS account. So the production sandbox is nothing separate but a specialized AWS account. Let's take an example. Proof of concept. What do you want to prove? Do you want to prove the value of a business, a question, or you want to prove the value of a technology? If you're doing a proof of value for a technology, saying, hey, there is a new technology in the market and we want to evaluate the technology and see whether it's good or not, those kind of POCs are better to be done in a lower environment, right? Because you're not proving any business outcome. You're proving the technology outcome. Whereas this is case where you're trying to solve a ML problem, right? A business problem associated with it. And your production sandbox will always come with whitelisted capabilities. You cannot install anything else. Which means, you prove out your value here, you have a model, and what you did is you package the model, because now you have to move the model from production sandbox, the package from production sandbox to, we call it as a production automation, right? So another account. So gold and redshifts are also production automation. So you typically toss it over to the gold or not redshift, but ML as a product, right? Instead of data as a product, you toss it over. That path of moving or tossing it over can also go through dev, QA, back to production. It's possible. And why this sometimes happen is because you want to prove out, for example, you're stitching together to create some kind of a CI/CD pipeline, right? So you want to prove out whether I have, my packaging was done correctly. So you package it here, it's called P1. You deploy the package in dev and ensure that the package is deployed correctly. You're not evaluating the model per se here, but you are evaluating whether my automation is correct. It's very difficult to replicate the data from production, like these data, back into dev and QA, right? I've never seen clients do that. If some clients do that, then probably we can build that production sandbox into something like a dev sandbox. So maybe it's a norm then in life sciences where you say, if I open my bronze layer in dev and QA and production, it will be exactly the same, right? If you're building something in dev, your model accuracy should be ideally the same as the production sandbox accuracy, right? So in that case, it's correct. Also, Databricks specifically tells us that when you build and package a model in a lower environment, like production sandbox, but within the production sandbox, let's say you want to move. So again, there are two constructs, right? One is dev, QA, and production physically. But within the ML also, what we typically do is, it's a production sandbox, but you have three kinds of Databricks workspace. And we call that also as dev. Actually, they start with none, dev, staging, and production, right? So this is just a logical construct, and this is typically managed in ML flow. So I'm running ahead of myself, but again, long story short, what typically happens is you build a model and you put the model into none initially, and then you register into dev. Ideally, and you have another workspace. So typically in Databricks, you have multiple workspaces, but all of the workspaces are actually deployed in the production sandbox. So physically, they're not different. So what we are trying to tell, or what Databricks tries to tell us is, when you move a model from dev to staging, do not move a packaged model. Move the code and retrain the model again. So your model should be retrained. They highly advise that the model should be retrained in every environment, even if the environment is just a logical construct. So if you follow that philosophy, then yes, typically you should retrain the model in every environment. Production sandbox is not only for data science, it is for any kind of exploratory work, right? So I do not have a use case in mind. I have to write and build out an ETL use case. Even then, you need to design something in the production sandbox. Why? Because regulations might also tell you that because every company brings in third-party data, they do not even have their dev pipeline, which means you cannot put a third-party procured production data into your dev. Sometimes what you do is, they will have some dev data, third-party data, and then say, oh, this is our dev data for testing. Test it out, ensure that the pipeline runs, change the API URL or endpoint, and then bring data from your production to production. So sometimes, even if you have the willingness to sort of keep your data in sync between dev, QA, and production, it is legally not possible. You cannot put your third-party procured production data into your dev environment. So hence the entire concept of production sandbox is very critical. It not only saves time, but then sometimes there is no other way for you to get access to your production data, to an actual live data, or to actual understanding of the data. Because for data science work, you need to feel that data. What does it mean to create the production setup, right? So it means that we can now help our customers set up something like this. So you have a production data lake where you have your curated domain-specific data, purpose-fit data, which is like data products. You have a non-production data, which is like bring your own data, right? So for a particular model, you might need some weather data, public data that you do not even have it in the production environment yet. So just to prove out the value, you sometimes use your production data, read-only copy, and you bring in your non-production data, and then you have to use it for different personas, different bucket structures. You have to share the data, you have to push the data into production, and then clean up. So to use your data and create an outcome, you need an exploration control plane, and that's something that we can provide as a value add within Accenture, right? So what it means is the right security. I have two projects, let's say, in the production playground. One project is with HR data, and another one is with let's say weather data. I have to ensure that the data scientists who are tagged with HR data science role, they should have access to HR data, even read-only access to HR data. We cannot have HR data available to everybody in that playground. The playground cannot be a hot hub for all PII data, right? So access control, security in terms of RBAC, ABAC, the guardrails, they have to be super crisp. Self-service, right? So the intention of the production playground or for the data scientist is to ensure how quickly without a lot of IT support, they can bring in the data and get some value, right? So what can we enable? How can we ensure that they can connect to all these data products? They can get access to the data, they can bring the data, pre-process, prepare the data, and create the data into something more tangible. Same with guardrails, right? So again, freedom is a two-way sword, right? So we tell the data scientists that, hey, this is a production playground, do whatever you want. We have given you the right access and the right data and the right tools. Sometimes, what we have seen is these projects, they'll create an MVP. The project lies in the MVP stage forever. They start talking to the business that doesn't care where this job runs. They're getting a report on a daily basis. So this data science team, they're supporting a production report through the playground, and after 6 months, one of the data scientists leave, and the business comes back and say, hey, you know what, I was supposed to get this report, I didn't get the report. And we find that report nowhere in our production, right? We see that they have created a shadow IT. People have been using the playground area to run small projects and power some really critical reports. So guardrails are important to ensure that we provide them the right access, yes, but at the same time, there are certain do's and don'ts, right? So all of that together, when we build these solutions, when we provide the right kind of control, that becomes the right setup for the production playground. So this is just another side of the story that, creating the production environment means providing them access to a particular location, at the same time providing them with the right control plane to ensure who can do what kind of work. Finally, one last slide on the third step. So we talked about the process, we talked about the maturity. Now we are talking about the platform itself, what it means to create a production playground, the guardrails, and last one, what is the structure of an ML project. So this is something that has worked for us. So your data assets, typically have a dedicated bucket that says these are the data assets, and you can categorize your data assets with name of application name, source name, feed name, and entity name. It's a naming convention that we have followed for data, all data analytics work, saying what is the right folder structure, right? So we found this folder structure is important. Then you can have a project and partition, right? The partition can be yearly, daily, monthly, how frequently the data comes in. Your lookup data should have the same one, the public data should have same, and your models should have project-wise distribution. So if I open up a repository where all my project artifacts are saved, I should have dedicated location for testing data, validation data, all of these version controlled so that I can reproduce these runs. Testing data, the models, the binary model outcomes themselves, the metadata of the model, and the reports, right? So some of the reports can be drift reports, profile reports, or other artifacts like how data observability reports, let's say, or some kind of graphs and charts that talks about the data distribution report, right? So all of that can be saved. So again, this is a experiments bucket structure. This is the structure of a ML project that has worked for us. It has helped us to easily demarcate data in the right way, provide the right kind of access control. So now I can provide IAM policies as to who can get access to the entire project 1 folder, who can get access to all other project 2 folders, right? So that way it becomes easy to provide access control and whatnot. Again, repeatability, auditability, everything is built in, because now you can open it up and you can start looking into the test results that you had, let's say, last month. So all of that becomes a simple way of maintaining and managing ML projects. So I want to pause here for today. We talked about the 3 things: the overview, we talked about the maturity assessment, we talked about setting up the environment, so the folder structure. Next week we'll talk about the implementation project, what is the entire way of actually implementing an ML project, the users and personas needed to operationalize it, and then the ops part. And then if time permits, we'll do that next time, or maybe we'll have a third session talking about how we have converted that into some kind of a tangible asset.